So this is the chip we're using in this lab. And this chip is available in 3 flavors. The one we have is the 4902, which is the 8-bit. And they're drop-in replacements. So if in the future you ever needed higher resolution, you could use a different one. So if you look at the signals, BDD, if you've had the devices and you remember a FET, like an in-channel FET, the drain is up here, and that's usually the plus voltage is biased on the drain, and they usually call that the VDD. So VDD is the plus 3.3 volts, and then which goes with that, the VSS, the source over here. This is how I always remember these, is from a transistor. So the source is the ground. So these two pins power the chip. If you're in the digital class, they usually have a VCC for the collector and VEE for ground, or just G and D. So the pins that are labeled NC, those are no connect. They may connect to something inside the chip, but they're for our purposes, we don't need to use them, and it's probably a bad idea to connect anything to them unless the chip manufacturer says to. So the signals we talked about before, the SDO, SDI, SCK, and chip select, well, so there's one thing that's a little confusing, is if you're at the microcontroller over here, so here's the microcontroller, and we have SDO, SDI, SCK. SDO, serial data out, goes out of the microcontroller. Serial data in comes into the microcontroller. The serial clock comes out of the microcontroller, and the chip select comes out of the microcontroller. So the way they've labeled this chip is this SDI is serial data in to this chip. So the serial data out of the microcontroller is hooked up to the serial data in of this chip. The two more NCs. SCK, that's a serial clock. That's the chip select, active low. And then there's a shutdown pin that we don't use. That I'm not sure what it does. Might put the thing into a low power mode or something like that. Shuts off the output amps, it looks like. So the shutdown pin is active low, and so in order for the DAC to work for us, we need this to be pulled high. The LDAC pin is when you strobe it low, it will I think it's on the diagram here. LDAC is right here. So as we send data into this DAC, this DAC has 2 outputs. There's a Vout A and a Vout B. Vout A, Vout B. And so when we shift the data in, the data shifts in versus time, right? So it seems very fast to us, right? We're shifting data in very fast, but it's definitely, we do one and then we do the other, right? So we could shift this data in to this register A, and then a little later we shift data in here. If these registers, as we shifted this data in, if they went straight through, were converted and put on the output, you'd see this output update, and then you'd see this output update. So they would stagger. They'd update in a staggered fashion. The LDAC, what it does is there's a secondary set of registers in here that once the data is shifted in, it'll sit in these registers temporarily, and then when you strobe this LDAC line low, it copies from these registers into these registers, and then the DAC conversion happens and the output happens at the same time. So both get updated at the same time. And so everybody in here, I think, has seen the lab where we're drawing stuff on the screen. right? So we're trying to draw our name on the screen. And what happens though is if you were trying to go from this point to this point, and the two DACs updated out of sequence, what would happen is the beam on the scope, you'd see the X channel update, then the Y channel update, and so you get a little dwell here. So instead of getting a dot here and a dot here, you get kind of this update happening like this. But by using that LDAC and allowing the DACs to synchronize together, the signal will go from here straight to here. Okay, so when we used the ADC, it was a little simpler. The reference voltage for the ADC is it's built into the microcontroller. It just taps off the power supply voltage for the reference. On these guys, there's a separate reference voltage input. So you've got to supply 3.3 volts for those references. And then the output, those are the outputs of the two DACs.